Okay, June 19, International Paper 1, question 17. This one's about submarines and Stokes' law and falling through stuff and viscosity, that sort of stuff. So, first part of the paper, well, not paper, first part of the question was the definition of some words. And this is not on our spec anymore. This is on the international spec only. So, for your information, strong means it takes a large force or large stress to break, whereas tough means that something can withstand impacts without breaking and absorb a lot of energy before they break. But we sort of don't care. And in fact, we've adjusted the grade boundaries to take into account that you weren't supposed to know this, and this just slipped through. That's this part of the question. The rest of the question you should have been able to do. So, the submersible had a mass of 11,800 kilograms. It descended at a steady speed. Complete the free body diagram. So, you had to be careful here. A free body diagram, the arrows have to touch the object. In fact, the arrow should come from the centre of mass, but that's very difficult in this situation because we've only got a little dot here, and although most of you realised that the force downwards was going to be the weight, you also realised that you need two arrows upwards. Now the examiner said they were quite generous here. Really you should be using a ruler to draw straight lines, but they let people off. So you've got a choice. The two forces that are acting upwards, now bear in mind it says it descended at a steady speed, so there should be zero resultant force on this, so the two forces upwards should equal the force downwards in magnitude. So you could do it like this, draw an arrow that appears to be the same length and label it with the two forces. So for example, up thrust and drag. Or alternatively, I'll do another version over here, we could have weight downwards and then two little arrows next to each other upwards, up thrust and drag. Either of those would do. Some of you did stuff like this, and I'm going to exaggerate a bit, but you sort of went, that'll do for weight downwards, and then, oh, that'll do, that'll be up thrust, that'll be drag. No, they're acting vertically upwards, and that's important. Okay, next part of the question was pretty easy, as long as you realised what they meant by resistive force. That's basically water resistance, and in our context, water resistance is the drag. So we're being asked to calculate the drag on the submersible. Now, if you glance at the diagram, up thrust plus drag equals weight. So that means that the drag must equal the weight minus the up thrust. So that should be quite easy. The weight is just going to be the mass, 11,800, which is earlier on in the question, but I'm not going to move the piece of paper, times 9.81. And that should equal, now I should reduce the number of significant figures here, but I'm just going to leave this in for working out, 11,578 newtons, and then we need to work out the up thrust. Up thrust, you should know by now, is the weight of the displaced fluid. So that's going to be, given that they've given us the density, it will be the density multiplied by the volume, that gives you the mass, multiplied by G. So up thrust equals density times volume, tells you the mass, times G. And when you substitute the numbers from the question in, I think, because I've written it down a bit weirdly, 114071. So we need to find the difference between the two numbers now. So the drag equals this number minus this number, and that is 1687 newtons. That's that part of the question. Let's go to part C. Okay, it's not part C. It's part I, but let's go to it anyway. So this time, what we're being asked is what needs to happen for it to make a return trip to the surface. So basically, the volume of the submarine is going to stay the same, so the upthrust is going to stay the same. There you go. So what we need to change is the weight of the submarine. And for it to rise, we need so that the upthrust is just bigger than the weight. So we need to reduce the weight to be the same size or slightly smaller than the upthrust. So I'm just going to write that here. About U equals the weight. That's kind of the cut-off point, at which point it will start to be able to rise upwards. So weirdly, that's going to be the same thing as we did in the last question. We're going to find out what is currently the difference between the weight and the upthrust. So weight minus upthrust is going to equal, from the previous question, 11,5758 minus 114,071 1687 newtons. So basically, the submarine needs to weigh 1687 newtons less. So how much mass does it have to get rid of? Well, using W equals mg, the mass is going to equal 172 kilograms. And then the final question. And this final question is really easy if you read the question. And about half the class read the question and the other half didn't. People that went wrong just went, oh look, a graph, I'll describe it. As the temperature increases, the viscosity decreases. But that's not what the question's saying. The question's saying that as you go down in the ocean, the temperature gets colder. So as the temperature gets colder, the viscosity increases. And you should be able to think how that's going to affect the falling through the water. So you're basically looking for this logic. As you go deeper, it's going to get colder. The graph tells us that as it gets colder, viscosity increases. Now it would be tempting to immediately jump to so it goes slower, but you haven't really explained why. So what would increasing the viscosity do? That would increase the resistive forces, or what we normally call the drag. So that means, and now I can't write, I'll try again, that means it's going to go slower. The end. Bye-bye.